Differentiation of implicit functions. Implicit functions are defined by the relations of the form f of x, y equal to 0, where the variable y cannot be isolated algebraically as a single term. I've given you a few examples, two to be precise, where y cannot be explicitly be isolated from the algebraic function. Two steps in order for us to be able to differentiate such kind of functions. We need to find the derivative dy over dx. Therefore, the first step is to differentiate with respect to x both sides of the given expression using chain rule when you see that there is a relation with y, since y is also a function of x. Rearrange the equation algebraically to isolate dy over dx, making it the subject of the expression. Here are some few examples to implement the previous steps that have already been cited. The question says determine dy over dx for the following. Number 1, we're given 3y to the power 4 plus xy squared plus 2x cubed minus 6 equal to 0. The first step says to us we need to differentiate each term of the given expression. As you can see, I've written explicitly here d over dx of 3y to the power 4 plus d over dx of the second term plus the derivative of the third term plus the derivative of the fourth term equal to the derivative of the expression on the right hand side, which is 0 in our case. Note that the second term xy squared, we have to use the product rule in order for us to find that derivative, because y is also a function of x. And for the first term, we'll differentiate 3y to the power 4 as if y is x, and remembering that we use the chain rule again, that we differentiate y to the power 4 with respect to x will definitely yield 4y cubed multiplied by y prime, which is dy over dx. Hence, the next step gives us 12y cubed dy over dx plus the product rule. In xy squared, if we differentiate x first, we will get the first term as y squared plus x times the derivative of y squared, which will give us 2y times y prime, plus the derivative of the third term, which was 2x cubed, gives us 6x squared, and the derivative of the fourth term, which was 6, gave us a 0, and the derivative of the right hand side also gave us a 0, so we just have equal to 0 there. What we do, we rearrange everything and isolate dy over dx, making it the subject. Please check. The first thing we do, we take 6x squared to the right hand side, it becomes negative 6x squared, and then take y squared to the right hand side as well, giving us minus y squared. And then on the left hand side, we'll be left with 12y cubed dy over dx plus 2xy dy over dx, and then take dy over dx out as a common term, and then you'll be left with 12y cubed plus 2xy. Therefore, if we make dy over dx the subject of a formula, that's the answer you will get. Please have a pen and paper with you and work out the steps so that you can be able to see whether there are no mistakes in the steps. Fill in the missing steps that lead us to the answer. Example 2, we're given 2x cubed y plus the second term is y squared plus x all to the power 3 equal to x to the power 4. First step requires that to differentiate each term, and it's given there in the first step. Note that the second step shows you the terms that are a result of those derivatives of the first term and the second term. The first term yields 6x squared y because we have to implement the chain rule as well as the product rule. Product rule requires that it depends on you, of course. You may start with derivative of 2x cubed or start with the derivative of y. So I chose to start with the derivative of 2x cubed, which gave me 6x squared, and I took down y as it is, plus take down 2x cubed, and then the derivative of y with respect to x. Plus, now we go to the second step, which is a composite function, the derivative of a composite function. So we have to use chain rule there. First thing, we have to find the derivative of the power function. So we know the derivative of y squared plus x all to the power 3 will give us 3 times y squared plus x all to the power 2. That's the first thing. Then we go inside, find the derivative of y squared plus x, which gives us 2y times the derivative of y with respect to x, because y is a function of x, therefore we have to use the chain rule, and also plus the derivative of x, which we know is 1. And then we go to the right hand side, the derivative of x power 4 gives us 4x cubed. Therefore, rearranging this whole expression and making dy over dx the subject of the formula, note that in place of dy over dx, you may write y prime. That is okay. If we make y prime the subject, then all the terms on the left hand side go to the right hand side that do not have y prime. So that means we end up with that 4x cubed that we had on the right hand side, minus the first term on the left, which is 6x squared y, minus the third term. Third term multiplied by 1 is the one that we are going to take to the right hand side. Remember that bracket multiplies 3 into y squared plus x all squared, divided by, okay, the first term that has got dy over dx on the left was 2x cubed. We write it down, plus we need to do that multiplication. 3 was multiplying 2y, so that gives us 6y, and therefore multiplying y squared plus x all to the power 2. Please check my steps and fill in the missing steps. Your next step should be the one that has the first term taken to the right hand side, and then the third and the fourth term simplified out on the left hand side, and then thereafter, the next step, we'll take all the terms that do not have dy over dx to the right hand side and take dy over dx out as a common factor on the left, and then check whether you'll get my answer that I have there for this question. Examples 3 and 4 as follows. Number 3, cot 2x minus 3 cosec xy equal to y squared. Finding the derivative of each term yields negative 2 cosec squared 2x. I'm hoping we still remember the derivative of cot is negative cosec squared. And then because the argument of cot is 2x, the argument of negative cosec squared will also be 2x. but that answer must be multiplied by the derivative of the argument, which is the derivative of 2x, which gives us 2. Hence, we have negative 2 cos x squared 2x. Then we go to the second term, which is negative 3 cosec xy. When we find its derivative, negative 3 is taken out, and then we find the derivative of cosec xy. We start with the derivative of cosec. We know cosec gives us negative cosec cot, whatever the argument there is. So therefore, we'll have negative cosec xy cot xy. Note the argument of cosec does not change. Then we multiply that by the derivative of the argument of cosec, which is xy. Therefore, the derivative of xy is x dy over dx plus y. You may exchange them, it doesn't matter. Equal to, on the right hand side, the derivative of y squared is 2y multiplied by dy over dx. You need to remember, every time you find the derivative of the variable y, you need to use the chain rule because y is a function of x. Please check my steps and see if you are going to get dy over dx to be equal to 2 cosec squared 2x. Note it's positive now, minus 3y into cosec xy cot xy. Please make sure that you got the right numerator. Then you go to the denominator. All the terms that had dy over dx. Then it means that you'll have 3x cosec xy cot xy minus 2y. Please check the steps. As I had said earlier, you need to have a pen and paper in order for you to write down each step and check whether the answers that we have here are correct. Let's go to example 4. We're given arcsine of x plus y equal to x squared. We start with the derivative of arcsine, which is supposed to be straightforward. We know if it's arcsine of u, you would have 1 over the square root of 1 minus u squared. Now the argument is not u, it's x plus y, hence we have x plus y all squared in place of u. But then you have to multiply by the derivative of u, which is the derivative of x plus y, which gives us 1 plus dy over dx, plus the derivative of y, which is the second term on the left hand side, is dy over dx, equal to the derivative of x squared, which is 2x. Now rearrange those terms, simplify, and I've left the answer blank. Please work it out and make dy over dx the subject, and let's see what you will get on the right hand side. Exercises based on implicit differentiation. We're trying to find the derivative of y with respect to x for all these 6 questions. Number 1, we have 2 arctan of xy plus x equal to 3. Number 2, we have y equal to x minus ln squared of x plus y. Number 3, e to the power x times e to the power y plus e to the power x plus y equal to xy all to the power e plus x plus y all to the power e. That would Be very interesting to see what to come up with for number 3. Number 4, we've got log of x cubed over 3 plus log of x over 3 all to the power 3 equal to log of y over 4, square root of y over 4 plus the square root of log of y over 4. Note on the right hand side, the first term is the log of the square root of y over 4. So the argument of log is the square root of y over 4 plus the square root, and the argument of the square root is log of y over 4. Please note those differences. Then number 5, left hand side is 9 to the power 10 of 9xy equal to, on the right hand side you've got 10 of 9xy all to the power 9. Lastly, you've got y plus 1 equal to x arc of y plus arc 10x. Work these out and let's see whether you understood the principles of implicit differentiation. Then we move on to logarithmic differentiation. This process of finding the derivative of functions that are kind of complicated, and they sometimes involve products and quotients and powers all in one or separately. What you need to do is to introduce the natural log on both sides of the equation, and then you simplify before you find the derivative. So let me break this down into different steps. Step 1, if the expression is complicated, introduce the natural log on both sides of the equation. That's the first thing. Check how complicated your expression is. Can it be simplified? If you see that simplifying it would take a long time, the best thing to do, just introduce the natural log to both sides. Step 2, simplify the expression using laws of logarithms that are applicable to that kind of expression. Remember, the log of a product xy is always equal to the log of x plus the log of y, and the log of x over y will always be equal to the log of x minus the log of y, and the log of x to the power n will always be equal to n multiplied by the log of x. I hope you still remember those. I've just mentioned 3, which are the most basic. So we use those in step 2. And then when you get to step 3, take all the derivatives of all the terms that you have found in step 2. And then thereafter, you make dy over dx the subject of the expression. And note that it is imperative that you substitute the expression that was given to you originally for y. Let's do some examples so that we can be able to apply all these 4 steps and see if we're going to get this right. Making use of log differentiation to find our derivative of y with respect to x. The first expression of y is in the numerator, I've got x squared plus 1 into x plus 3 all to the power half, and all of this is divided by x minus 1, and the restriction is that x must be greater than 1. First step requires that we introduce ln to both sides of the expression, and that's exactly what we've done there. The next step, step 2, requires that we simplify using the laws of logs. So therefore, the right-hand side is ln of x squared plus 1 plus. Note that we had x plus 3 all to the power half. That means it will be half times ln of x plus 3 minus ln of x minus 1, because x minus 1 was in the denominator. The next step, step 3, requires that we find the derivative of each of those terms. Therefore, the derivative of ln y, of course, is 1 over y multiplied by y prime. Chain rule for any expression that has got y. And then, first term on the right, derivative of the argument of ln is 2x, and ln yields 1 over its argument. Same for the second term, it's half times the derivative of x plus 3 is just 1, hence we have 1 over x plus 3, minus same for the last term, we have 1 over x minus 1. And then we make d over dx the substitute of formula. That means we multiply by y on the right hand side, and the answer, the final answer, is where y has been substituted back into the expression. And the expression that was given to us for y is the original expression for y. Hence, we substituted it there in place of y, multiplying the whole other expression, other three terms on the right hand side. Let's go to example 2. Y is equal to cot cubed x 10 x squared, all divided by 3x squared plus 1 all squared. Again, first step, introduce ln on both sides. That's exactly what I've done. Note that I tried to simplify the numerator so that it makes sense when you find the derivative. Cot cubed x is the same as cot x all to the power 3. Then, simplifying using the laws of logs, we get on the right hand side, we get 3 ln cot x plus ln 10 x squared minus ln of the denominator, which is the same as minus 2 ln of 3x squared plus 1. And then from there, finding the derivatives. Right hand side, the left hand side is, we know it's y prime over y. And then if we take y to the right hand side, that's what we get. The derivative of ln cot is minus cos x squared over x divided by cot x. Please check my differentiation. And the derivative of 10x squared, the derivative of 10 is sec squared. Please make sure that everything is right. The derivative of x squared is 2x. All of this is divided by 10x squared minus the derivative of 3x squared plus 1 all squared is 2 into 3x squared plus 1 multiplied by 6x. All of this is divided by the argument of ln, and then substitute y in, and you make sure that everything is fine. Number 3, y is equal to ln of the square root of x squared minus 1, and all of that is multiplied by sine x. First things first, Here you don't need to introduce ln, as you can see. All you need to do is to simplify the right hand side. Half ln of x squared minus 1 plus ln of sine x, and then find the derivatives, and then you get half of 2x over x squared minus 1 plus cos x over sine x. I'm hoping you're noticing when you already have ln on the right hand side and you can simplify it, there is no need to introduce ln to both sides. Just go straight forward, simplification, and then differentiation. After differentiation, we simplify again. Half and 2, they cancel each other out. Cos x over sine x is cot x. As we complicate matters, we have y equal to 7 to the power x, e to the power xy in the numerator. Denominator is sine of 3x all to the power cos y in the denominator. Find the introduced ln on both sides in order for us to find this derivative, which is y prime, and then simplify. I'm hoping you're noticing that we've got ln of 7 to the power x plus ln of e to the power xy minus, I'm hoping you're noticing that we used the power log rule. So that means we'll have cos y times ln of sine 3x for the third term. And then find the derivative of each term. So we'll have ln gives us 1 over the argument. So we're supposed to have 1 over 7 to the power x multiplied by the derivative of 7 to the power x. Please refer to the tables. And then we'll get 7 to the power x ln 7. Next term, ln of e to the power xy gives us 1 over e to the power xy multiplied by the derivative of the argument of ln. The exponent does not change, so it remains e to the power xy multiplied by the derivative of xy, which is y plus x y prime. I'm hoping you still remember that we use the product rule. Minus. Now we come to the product of cos y and ln sine 3x. We start with cos y. The derivative of cos is negative sine, and the derivative of the argument of cos is y prime. Hence we have negative y prime sine y times the second function as it's not changed, and then plus cos y into the derivative of ln sine 3x, which is 1 over 3 sine 3x, multiplied by the derivative of sine 3x, which is 3 cos 3x. We try simplify, removing all brackets and making sure that y prime is on the left hand side. So all the terms that have got y prime, we shift them to the left hand side so that we can make y prime the subject. Please check my steps and also check the final answer whether it is correct. As we complicate matters, number 5, please work on it, guys. Work on it and see whether I've not made any mistakes, and check to make sure that everything is correct and I've applied all the steps and I've applied the rules of logs appropriately. And check whether also you'll get the same answer as I have there. Here are your examples or exercises. Examples or exercises for you guys. Please check on them on the TUT Blackboard, or we call it My Tutor, you'll find these exercises on the class tutorial exercises. You'll find them on page 22, and some answers have been provided for you for those exercises. Please check whether your answers correspond to the worked out answers that have been provided.